I think a doorknob is an interface.
Okay, and
Allows you to open the door. Without the doorknob, the door is, if it's closed, you can't open it.
Yeah, but I can kick it open though.
Getting back to the
Well, then
vehicle.
your foot is an interface, Jim.
what are you gonna say, Travis?
I was gonna say, getting back to the vehicle that you were talking about, if it was of class car, then like a steering wheel would be an interface with that.
I like that, right? Because I'm turning it and the car turns. Do I have any idea how it turns or what's actually happening when I turn that wheel? And
I don't think you do.
I don't.
I know.
Some of you might, but I do not. I've seen pictures and I have an idea, but do I actually know specifically what is happening? Not at all. And can you guarantee though that exactly what happens in one car happens in every single car, even though they all have a steering wheel?
No.
No. I turn the same way, regardless of what vehicle I'm in, right? Whether I'm in a bus, a car, a truck, whatever, I turn the same way, right? On the wheel and it turns.
But, if your steering column is
is
broken, your wheel's just turning like going nowhere and your car's just going straight. Yeah.
not the point. Stay focused. So yeah, I have the steering wheel and all these different vehicles. I turn that wheel, the car turns. If I turn to the left, it turns to the left. And that might be, I don't know how that looked on the camera, but if I turn to the left, I go left. If I turn right, I go right. But can I guarantee that when I turn the wheel, the exact same thing happens in every car to facilitate that movement? All right. And that's one of the cool things about interface abstraction. We use a similar item to interact with similar things, but we interact, how that interaction is performed is different based on the items. Let's see.
I read a good analogy that was like
Don't.
drawing, like,
Yeah.
you know, you could draw with a pen or you could draw with a pencil or a paintbrush or any sort of thing, but you're more or less doing the same action.
Yeah. Yeah. And for Elaine's two examples, like the doorknob, honestly, yeah, that could actually work as an interface because how that door opens could be different. You could have a knob and you turn it just like in every other door, but what actually happens, mechanics that causes that door to then unlock could be different. We're used to the thing that just slides out. You could have ones that actually go up and down so that you turn and it brings the two pieces down so that you can then open the door. There's multiple different ways of implementing a door with a knob and how to open it to get in. And so the knob could be argued is an interface. So that one I never thought of before. It's a nice one there, Elaine. What was the first one you also gave?
Oh, the power
Plug,
cord.
right?
Yeah.
I wouldn't say the plug is, because the plug is pretty much the same for every computer, but the outlet that you plug into, right? That plug in the wall is definitely an interface to the electric system. You can plug in laptops, TVs, lamps, vacuums, VR systems. You can plug anything you want into that same outlet and it works the same way, right? That outlet is definitely an interface for your device to work with the external grid. How that external grid is generating the power, getting the power, your devices, your lamp, your computer, your laptop, your tablet, your phone, your vacuum, doesn't care how the electricity is being delivered, just that it can get it from that interface. It's like, hey, I need energy, and it gives it. And so that's the idea of interface. Interfaces, what they do is they guarantee behavior. They're a blueprint that says, here's how as this object, when we implement this interface, here's how you interact with this type of object. So if I have, in this case, in a game, we have actors in games. And those actors can be anything from monsters to NPCs to players, right? They're all actors. But when you ask that actor to do an action, how that action is delivered is different, right? We're actually gonna dig into this mostly when we get into our card games. So we're gonna actually create, the card game we're gonna create together is Blackjack. And we're gonna implement both the player and a dealer. They're both actors, and technically the player and the dealer both have the same actions available to them. But what's special about the dealer in Blackjack?
They cheat.
Yeah, 100%. I agree.
I wouldn't say they're cheap, but they are definitely designed on a curve. But how do the decisions for the dealer made?
I don't play blackjack.
Can you ask that question again? What do you mean?
Yeah.
How are the decisions?
So we have, so in blackjack, there are several actions that a player can take. You can
Yep.
hit, stand, double, and split, right? Those are the 4 actions you can take in blackjack.
Right.
A dealer technically has those actions available to them because they are a player. However, what is different though?
Well, they can't do all the other actions. They either
Why
can
can't they do
hit
that?
or they can stand.
But why can't they do those actions?
I mean,
It's not the game that enforces the rules. Blackjack doesn't enforce those rules.
because they're the dealer.
Right, but again, and who defined the dealer? Technically, where did the dealer come from?
The casino.
House.
Right, it's the casino rules, right? It's not the blackjack rules. If you and me decided to play, Carlos, if you, me, and Lane decided to play blackjack together and you were the one dealing out the cards, are you now bound by the dealer rules? Or are we playing against each other?
We're playing against each other.
Right, you're not gonna be bound by those dealer rules, are you?
Right.
Right, and so that's something to keep in mind, is that when you're playing the casino, yes, the dealer there has rules. So we can now implement the dealer in our game for that if we want to, right? And so while the dealer in the casino has access to the same options, the casino says, no, you can't do those actions. These are the actions you can perform and when you can't perform them. So in this game with blackjack, we'll ask the actor, hey, what do you want to do? Via an actor interface, the player who is implementing an actor interface will say, we'll actually get to ask via the console, hey, what do you want to do? Here's what you have, what do you want to do? And the player will type into the console what they want to do, and it will take that action, right? When the dealer is the actor though, and I ask the actor there, what do you want to do? The dealer on this hand, which is implementing the actor class, instead will go through its rules and decide which action it wants to take based on its rules,
Yeah.
and then return the action it's going to take. The game itself,
It's almost hard coded.
yeah, the game pretty much it is, and that's what's really cool about this. You guys will actually, with me, work through creating a decision tree AI. Technically, it's just a decision tree AI. It says if this, then do that. If that, do this. It's not any sort of like intelligent learning AI, but it is an artificial intelligence that's making a decision based on things based on the information it has. So you'll get to create your first AI with me. Sounds cool, but it's kind of a simple one. It's kind of very basic AI, but hey, it's the first one, so we get to have fun. with it.
Gotta start somewhere.
Yep, exactly. And so
Wait,
again, what's really
so-
cool about this is that the game, as far as blackjack's concerned, the dealer and the player are both actors. They both can do whatever they want. But how the decision is made, the game doesn't care. The game doesn't care how the actor makes the decision, just that it will provide a decision. And that's what the interface will allow us to do with this.
So would the interface be just the dealer, and the casino is the
No.
class?
Good question. Yeah, no, so you're asking, is the dealer the interface? No, in this case, no. The interface is actually the actor class. So we're gonna have a class called actor, or it's
Right.
actually an interface, not called a class, but it looks like a class. So it's an interface called actor. And interfaces are, just like abstract classes, cannot be instantiated. On the other hand, though, they
Defined by a
also,
method.
right? Well, wait. They declare methods. They
Right.
declare fields and they declare methods. They say what these classes will definitely have. And so it's kind of a contract. You can see it in interface like a contract, saying that any class that implements this interface guarantees that these methods and these fields will exist in it. That you can call these methods and check these fields and they'll be there. I can guarantee that these items are there. They have to be there. And so that's the slight difference. As we mentioned before, abstract classes and interfaces, neither one of them can be instantiated. So interfaces and abstract classes, you cannot instantiate them. The difference is abstract classes are inherited. They use the extend keyword. Whereas interfaces, they use a keyword known as implements. And so it's implements interface. Once you do that, you have to implement any methods that were declared inside the interface. Now, there's one thing I do want to clarify, and again, we'll review this again when we get there. Common practice for interfaces is to simply declare methods and not put any definition in them. And in early Java, that's what you had to. You could not define a method in an interface. In the more modern versions of Java, that has changed. You can put a default behavior in an interface method. So that way it at least has a default behavior. A lot of companies still practice the pure system where interfaces are just that. They declare methods, they do not implement anything. But they did this for legacy capabilities. So if you have items that implement an interface, your interface then gets more fancy and it has a new feature you've added to it. Instead of having to go all the implementing methods, or sorry, all the implementing classes and add this new method into it that doesn't do anything because these old ones don't do it, you can have a default behavior that'll then apply to all the child classes that already implement this item. So it is something you do, but we're not going to touch too much base on that. What I'm going to do to teach you guys mostly how to use interfaces, because I want to make sure you see the behavior in an interface. We're mostly just going to declare. We're not going to define anything in an interface. Just out of the way on the back of your mind, you can do that. You can definitely define a method. And for anyone wondering what I mean by declare and define, we are going to talk more about those terminologies as we go through these, because that's going to matter more now. We could never just declare something, a method in our previous work, so it wasn't really beneficial to kind of talk about those keywords yet. We can now do those things with abstract classes and interfaces. We can now declare only without defining. So now those terms are going to become more familiar. We're going to play with those words more. All right. So you're not sure what I mean exactly when I say declare and define. That's fine. We're going to be digging into that now that it makes sense to dig into those things. I've tried to like leak out those words periodically during the lessons, but they really didn't fit before. So now they're going to make more sense as we go forward. Other than that, that's pretty much what we're covering for the next project. Those are our three major topics that we're digging into for the next project. So only like a couple weeks, I'm thinking, probably 2-3 weeks max, I'm thinking. And then we go right into the next project. And after that, it's Spring Boot and then interview prep. So we're getting close. Doing pretty good. Like I said, I'm very, very happy with the results of this first project.
I'm on the 2-year plan. I'm sorry.
I don't think you are, honestly. I don't think you are. I don't think anyone here.
I don't want the
is right
pressure
now.
to think of like, oh yeah, I have to get this done by this date.
No, you don't. Definitely don't feel like you have to, but I'm saying this is what I'm currently seeing our current progression. It's possible, is what I'm saying. It's possible that we could be there.
So it's an interesting conversation with my brother-in-law this weekend because he's a director at a company which hires, developers. And I was asking, what do you use for your tools? Do you use HackerRank? He's like, no, we use HackerEarth. And I was like,
Earth?
yeah. And I think it was, I was like, does it have IntelliSense in it? He's like, yeah, we don't block you from using that. So I was that was very interesting conversation for me to hear, because that's a game changer in an interview if you have IntelliSense.
Oh, it does. Yeah.
The HackerRank mock tests have IntelliSense in them.
Ooh, they do now? Oh, nice.
Yeah, because the one I took, Cliff, had it.
Well, they must have updated it then. Nice.
No.
I don't remember. Yeah, I remember when I used to use it. I didn't. If the IntelliSense, for me, most of it was just IntelliSense is iffy sometimes. It doesn't always act up for me, so I tend to not like relying on it in IntelliSense.
Not relying on it, but it's nice to have.
Oh, 100% is nice to have. Trust me. Yes, that's what. And part of what I'm saying, like with the interviews, all I'm saying is you're not guaranteed to have IntelliSense.
For sure.
So that's what I'm saying. You shouldn't rely on it, but yeah, if you have it, see it as a boon. Definitely, that's gonna help you in the interview 100%. Yeah. And depending, like I know, like for a fact, like, and again, this one doesn't really affect you guys, for example, but Google, for example, will actually just have you code in a Google Doc. So there's no IntelliSense there. There's also no syntax highlighting in there.
Yeah.
You get nothing out of that.
Scary one.
Yeah, that
There's a
one's like,
text editor.
why? Literally, that's what it is. It's just a text editor. They have you code in Google Doc. I'm like, why? That's just being unnecessary mean. So that's how I looked at it. But again, that Google, you're getting paid decent, and they're looking for very strong developers. So that's why they do it. Some companies
Was that
don't
a
like-
junior development job?
I think so. Yeah.
Entry
they
level?
do it for
Yeah.
all of them. Yeah. They'll do it for their entire team because everyone wants to work at Google. You kidding me? So everyone's gonna be like, I want to work there.
I don't want to
So,
work
like,
for them.
Maybe not. A lot of people do, especially because I don't know if did I tell the story of this one? That like all the food there is free. And it's like chef.
Yeah,
level
I've
food.
had that before. We had free alcohol at Lucid.
Yeah, same thing. Yeah. Like I went into the Google place because Arnold did a Google talk there, and they walked us into the cafeteria for food first, and the guy just walks off, and I'm sitting like, am I supposed to pay for this? This is like, how expensive is this gonna be? I'm like, and I'm looking around for prices, and I'm like, I don't see any prices. Jesus Christ, this is getting me even more nervous now because they don't even look at the prices. Because who in Google's gonna care? They're getting paid enough for the food here. Like they don't really care. They're just gonna pay for it. And I'm like, ah, great. Like And I wasn't too surprised because yeah, when I went to the, like, for example, I went at the hospital, I went to the cafeteria in the hospital. There's no prices listed there either. You just get what you want, and if you either pay for it or you don't. So I was like, I wasn't too surprised when there wasn't prices listed at Google. So I'm like, I guess I'll get some of it. And then I look around like, but wait, there's no cashier either. And so I'm thinking like, what's
This
going
is
on?
awesome.
Yeah, I'm like, what's going on? And then eventually, I can't remember who said it, but it might have been Arnell. He's like, oh no, it's all covered by the company. The company pays for everyone's food if you work in the office. You know, obviously you can come get food and it's all here. It's like, and they're doing like, they're cooking it on site.
Oh,
I
yeah.
walked up and they had like, they were cooking the fish and the
Real
steak right
chefs.
there. Yeah, they handed to you. They were blending the smoothies right there in the office. They had like little
Yeah.
Starbucks like cafeteria place. And I'm like, this is
Their
insane.
idea too is just to keep you there as long as possible. So
Well,
if you
that's the
like
thing, yeah.
your working environment like that,
Mhm.
they're gonna keep
Yeah.
you there all day
100%.
and night. That's
And
the
some
idea.
people are willing to do that. And again, that's
Yeah.
what you get to decide. If you feel that they're treating you right, you're willing to do it. And that's something that some people can argue. I feel that I'm getting enough. I do feel like I'm getting enough benefit out of career devs itself. I put a lot of hours into this versus my pay. Do I?
Are you
Should I
getting
have
free
to?
food?
No, I'm not getting free food.
Time to find a new job.
But I do think maybe in the future I could. But I do feel like I like career devs enough and I like what I'm doing here enough and I'm learning so much from it and the connections I'm making is so strong to me that I do feel like it's worth it for my time. That I do value putting the time in. So that's how it looks for me. Like, yeah, Google is totally doing it to make you want to do it. You're not expected to, but they're trying to provide you the resources that you feel like, you know, I can stay here a little longer. I can work a little over hours because I like to be here. So it's definitely, yeah, you can definitely argue that's it. But they did also find that happier workers do work better. I think IHOP actually recently found that out too. IHOP recently increased all their employees to $15 an
Everybody
hour,
free
and they actually got a
pancakes.
profit. They actually started making a better profit because their employees were happier, they were making customers happier, and their employees themselves are actually buying some of the food themselves.
How did they make
Actually
them
afford
happier?
IHOP. What's that?
How did they make them happier?
By giving them more money.
Oh, yeah.
They paid them more. That made them
Yeah.
happier. They were less stressed out at home for one. They were less stressed out
usually
because
works.
they had more money to pay bills. Yeah, they were less stressed out at home, so they were more willing. They felt more like they felt more valuable to the company valued them more. They showed up. They treated the customers better. They worked harder, and they were less stressed out at home because they didn't have all of the debt as much. They had less debt, and they could buy
Yeah,
things they wanted to
makes
buy.
sense.
And not only that, again, they could afford the food they were serving. They could actually afford to eat at IHOP themselves. So they made
was
a
gonna-
profit
yeah,
for
I
companies
would-
and off their own employees.
They get free pancakes.
Probably, yeah, then with the discount, even with the discount, yeah. So, so like, yeah, you make your employees happier, they're gonna work better. Simple as that. And that's what Google's doing. That's their incentive. That's why they're willing to pay for the food. But hey, still good. I had a piece of fish, a piece of steak, I had a smoothie, I had a coffee, and I also
And
had
it's time for bed after.
pretty much. But I also wasn't working there that day, so I could eat. I was just there to be kind of join Arnell and watch his Google Talk. So I wasn't doing anything that day really. I was just doing networking, so
that's-
I was good.
That's fun. Yeah.
So I was happy, and I was just excited just to be in Google. I was like, I'm in Google. Which, for the record, you guys are all still kind of lucky that I'm here because literally while I was there, they tried to snipe me from them. It's like, oh, so you work with Arnell, right? You're the developer that he mentioned in his talk, right? Like, yeah, I was like, if anything doesn't work out well with Arnell, just send us your resume. I'm like, okay. I was like, all right. So if I didn't feel happy about Create as and confident what we're doing, I might have been at Google instead. So, except I would have had to move to New York, and that might not have worked. Anyway, hello, Christian found good stuff. Yep, you gave Christian the guy. Christian, I'm gonna have you and Evan look at that tonight, if you don't mind. So that might be a cool thing for you and Evan to take a peek at and see how that works. All right. So Christian found the Java coding tests on Hacker Earth, and apparently none of them have a higher than 4% pass rate. So on easy, medium, and hard. So there we go. That could be something fun to look at.
Jesus.
Yeah. Oh, that's a cool thing. I didn't know Hacker Earth exists. I wonder how old that company is. Why have I not heard of that one before?
The easy is only 2%. They're only 2%.
2%, huh? Dang.
Not easy.
But that's
Hard
easy. Well,
is-
then again,
hard
probably
is
everyone's
4%.
doing it before they're ready, probably.
Yeah.
I'm curious about how long it's been around. I have not heard of this one before. I'm
I don't think
surprised
I'll-
by that. I'm going to look into that more. Anyway, all right. So we have our three things that we're going to do. There are three main things we're digging into, plus Google, plus GitHub as well. Oh no, 2021. There we go. Yep. Okay. Oh, 2012.
20.
Dyslexia. I was like, oh, okay, no, it's okay. It's not that new, but new enough. Yeah. In the tech world, that's fairly new still. It's not super
I
new
don't know.
anymore, but it's still fairly new. Especially as I think HackerRank's been around like real early.
I forgot what he said he was using earlier, but they said it got too expensive.
Probably HackerRank. HackerRank is expensive.
Maybe.
Yeah. So GitHub and our three topics. What I want to touch base now on just a couple of two cool things that I kind of saw in some of the Liar's Dice applications. So make sure my screen is clean. And unfortunately, yeah, that's all in our video now. Fun. I just forgot I was recording, so it's fine. This class may only go, I might trim this one. We'll see. If I can. But let's go ahead and share screen. So the first one I actually want to take a look at was actually a cool little feature that Keith, you did that I didn't teach. So is this one yours? Yeah, this is yours. And so it was in the cup class. And so in the cup class, I saw the cup instantiate, like the cup constructor, and I saw that it didn't take any parameters. So I'm of course thinking at first, oh, I'm going to see a magic number. Let's say I see number of dice, and well, can anyone tell me what's happening here? The number of dice, what's going to happen if I instantiate this class?
Not gonna have any, the number of dice is not gonna be there.
That's what I thought first, right? We have 0 here, right? We have this int number of dice 0, right?
Yeah.
And so at first I'm like, how's this working? So what I caught though was this guy here, static. And remember what happens when you have static classes? What can we do with static? Oh, sorry, static methods. Let's say, sorry. When we have a static method, what does that mean? When a method is static, what can we do with that method?
You
It
can
can be used anywhere.
without instantiating an object.
You can access the method without instantiating the object, right?
Yep.
So it makes you wonder, can I access this variable without instantiating it yet? Can I access the number of dice variable, maybe modify it because it is public. It isn't private, and that starts at a funky public, but it is public and for all intents and purposes. Could I modify this before I instantiate a cup? And so that's what I was curious at first. So I clicked on this and went to references, pulled it up. In player, so I see here player. All right, so player is not doing it. Well, where is player being instantiated? There's that add. Oh, there it is, right here. If I scroll up just a little bit, we see cup.number of dice, scanner next int. Very, very cool use of static on there. That was really cool. I hadn't taught that yet, so I wanted to show people that system right there. That's really
I just
cool.
couldn't get it to work, so I was just using I was throwing whatever I could at it to make it work.
That's sometimes how you find cool things. And that's why I love to have you guys look at each other's code sometimes, because you'll see different ways of using code that, yeah, you may not need to use it in your version, but later down the line now you know that this static variable system exists. You can have static fields that can be modified, but then when you modify a static field, that modifies the blueprint. And so because he did this, that modifies anytime now I instantiate a cup, anytime I instantiate a cup, it now has this new value for number of die. So once I give it like the 6 or 5 or 3, whatever many dice I want, every time I do this players.add new player now, new player instantiates a cup that's going to use the new number of dice, not the initialized 0. Very, very cool feature there. Mostly just wanted to highlight that because it's really cool. I forgot to even teach that at any moment. I taught static methods, but I forgot about static fields. So mostly just wanted to showcase that because it's a very cool tool to have, and it can be useful if you ever have classes. But yeah, you need to instantiate a bunch of them, but certain fields can be changed, and you want to change the blueprint itself. So very good on that. And then one thing I want to mention, so as we get into abstract classes, you guys might want to, if you guys have problems with abstraction and stuff like that, or abstract classes, hit up John. John created an abstract game class. And so he kind of already got an idea of what abstract classes might look like. So if you ever get stuck on abstract classes, John Giat is the one to go talk to, which, oh, that actually just reminded me, I have an announcement to make. I literally forgot. And John's probably been like, when is it gonna happen? So everyone remember that unfortunately Joel had to step out of Creatives for personal reasons. And so we lost a TA. And so I've been trying to find one to take over for that and kind of make sure we have our 3 TAs at all times in case anyone current TAs are sick or have to go or do something different. And so I was eyeballing a couple, but then John himself kind of showed it to me on Thursday when he reached out when Mike was busy and said, hey, I can help. And so John was already acting like a TA, so I offered him the opportunity on Thursday, and he said yes. So John Giard is your new TA. So you guys have your 3 TAs again. So Mike, Freddie, and John are your TAs. If you have any problems, reach out to them. Again, they're supposed to be at least one of you a
What
week.
about Matt?
I think we need Matt, not Mike.
Matt, thank you. Did I say Mike? I said Mike, didn't I?
Yeah.
It's M's. It's the M's. So, yeah,
If you get
Matt.
demoted as a TA, does that go on your resume as well?
No, we would just say you don't put TA on your resume now. We have never, I don't think we've actually ever had to demote a TA. So it's always a good thing. And I'm not planning on it anytime soon. The TAs that we've had so far have been amazing. Really, really proud
They're
of them.
good. They're good. Yeah.
They're doing great work.
I think busting Matt, Matt up a little bit.
All right.
Keith, you like busting up everybody a little bit.
I was wondering if I wanted to say that. You're now in the new crosshairs.
All right, I gotta mute. This is on video.
It's all good. We're having a good time. This is a fun day. This is a fun class. So yeah, just quick item here. You can see abstract class game. Basically what it does, we have the setup method, which the game thing, which runs setup. You have the player system, which almost all games have players. So players is already built in. And the main thing I wanted to showcase is just these. These were those methods we talked about, abstract methods.
You're not showing the screen now.
I'm not again? Ah, dang it, I have to hit stop. I thought, oh, yeah, I wanted to do the announcement and have the screen up. Right, never mind, thank you. Anyway, as I was saying, abstract class, we have these methods that run in all games. All games have a setup where they create their players. He has these cool things with play account. I'm not gonna go into too details on them. The main items I want to show with these right here. These are your abstract methods. All games have them. All games have a play method where you start the game itself, where you actually start playing the game. All games have rounds, which then loop through the players. So the round is a single round where players take actions. Every game has a turn, which is a single individual player's behavior. And that's a turn. Turn is a single player behavior. And then of course they have the end of the game, which is the display result. So how do you end the game, right? So really, really cool behavior here. Really excited to see that. But yeah, if anyone has any questions about abstract classes when we get into it, as we start learning it, you know that there's at least one person that's at least built one. So we have a supporting person for you guys. So very excited about that. I'm glad, again, definitely confirmed my decision to make John a TA so he can help you guys out. You guys are stuck. Awesome. All right, so that's that. What else did I have today? What time are we at? 6:30 already. Dang, that went quicker than I'm bypassing than I thought it was. All right, I guess we can do a little code today. We do a little bit of I'll have to trim the video, but that's fine. I can do that in iMovie, whatever it is. We'll do a quick thing. We'll just kind of do a quick introduction to the access modifiers. We won't go into a big detail on them yet, but we'll at least introduce the access modifiers and what they stand, what they mean, what we can do with them. So, IntelliJ. And then what I'm also going to do for you, Christian, just so that it's ready, so anytime you and Evan can go, I'm going to open up the breakout rooms and make them self-assignable. So. 20 of them just needs to do this. Do an exercise where you guys break out. Yeah, as soon as you feel up to it, Christian, you can jump over into room 20 if you want, but you can hang out and watch if you want as well. So we'll do that. All right. All right, this is a cohort 14, right? Like, where'd my Yahtzee go? So here we are in this. No, not a class. I want to do a new package. So I'm going to create a new package. This is going to be called abstraction. That's what we're going to be teaching on this one. Abstraction. Our abstraction package. And that's something I was going to be digging into as well. So alongside with the access modifier is going to be packaging as well. So I'm going to understand how these work now. Create our new package called abstraction. We create a new Java class. This is going to be called main to start. We're going to create our main class, right? Hold on, actually, no, I don't want that. I want main class, right? Oh, no, wait, no. I don't need a main class. I just need a main method, right? Yeah, let's do instead. Method do I want to create? Oh, let's do a checking account. What happened? I stopped typing. Okay, that was weird. Checking account. Checking account class. And I am going to create a main method now that I think about it. So I'm going to create a checking account and a main class.
What's the first one? Checking account?
Checking account and main. And then that shortcut I just did there inside the main class, if you type the word main, it will create the default main method if you just hit enter on that. And so you get your
I
start
thought you
point.
had to type PSV.
Don't know that shortcut.
Yeah, it's the same.
PSV?
I think it does.
Ah.
Yeah, the same.
PSVM.
Yeah,
Ah.
That
Public,
one does
oh,
not-
but I like
static void
main better. Yeah.
PSVM, yeah, public static void main. All right, I see why I said, I'm like, why PSVM? PSVM. Okay, I get it now. Like, that doesn't seem intuitive. No, it does. I didn't activate it. Oh, I didn't activate it. Did I?
Yeah.
Open rooms. It's open now. Yep. Okay, cool. Close that. All right, cool. All right, we have a main, we have our checking account. All right, what are some fields for a checking account we have?
Account.
Account number.
Yep.
What data type should that be?
You want to make it simple, do it int, but if you want to be complicated, make it a double.
Am I gonna do math on it?
Well, oh, an account
Do a
number. No, you
string.
don't. No, oh, no, I thought it was like a balance. No, no.
I could do a string, couldn't we?
Yeah,
String, because we're not gonna do any math on it. We're not performing any calculations on this item. And this way we can also be fancy with it and do like a G dash kind of account number, right? Or a C dash for checking accounts. So we could actually be a little more fancier instead of just doing just numbers. We can do other items as well. So string. And I'm going to call this ID because it's a common term for account numbers and IDs. So we'll use that. And we're also going to do private now. We're going to start every single field now with private instead of public. So that's the first going to have, we're going to start breaking now. So I know we've been typing public all the time. We're going to start breaking our habits. Fields are going to start private. The time being. I might switch that for demonstration purposes to see what the differences I can do is, but for now I'll type everything private. All right, what's another field we have?
Balance.
All right. Balance. What's our data type for that? Ooh. I just do. Go away.
What did didn't Jim just say something about that?
What?
yeah, I did.
Then int, if you want it to be complicated, make it a
Can it be a float though?
float,
A
We
double.
do float.
double,
You can make
So-
it double or simple could be an int.
Yeah, I could do that.
or a float. Isn't a float
do that.
better?
If you want to make it super
question.
complicated, make it a string.
String down. I think we're gonna do calculations here. So there's actually, that's what I like about doing the checking account and dealing with money, because we got float, we got double, and that's all I've heard so far, right? Are there any other options I could do?
Along.
I do along.
Well,
What else?
let's hope we need a long in our checking account balance.
A
byte.
A byte. I would hope not a byte, but you could use a byte technically, but that would be that would be not a lot of money.
Maybe if that's my bank account.
Exactly.
The
yeah,
maximum
so
amount of money you could have in there, what is that? 256 or something like that? 512? Something.
On a good day.
56 cents.
256,000
56 units, whatever it is. Yeah.
units. Yeah.
So any other guesses? So I've been hearing a lot of like just decimal values, right? And so here's what's actually very interesting to keep aware of. So something called precision in computer science. So we did have that talk earlier about, let me go back to the white, let me switch over to the whiteboard for a second. We did have that quick little discussion of how numbers are represented in computers, right? How numbers are actually represented. Remember how that works? When I type the number 10, what does the computer actually know? What does the computer see?
2.
What's that?
2.
Yeah, if I was writing like this, I didn't realize I did that.
Yeah, so
Right. The computer sees 2 when I see 1 0, right?
The
We as
one-
humans see 10. And so if the computer wants to see the number that represents 10 items, Matt, what is it?
1100.
1100. So it's 1, 2, 4, 8, right?
Oh, sorry. No. 1010. Sorry.
yeah,
Oops.
101.
Yeah.
There, like that.
0, 1, 0.
Like that. Yeah. I
That's 10 in binary.
put my
I
4 in the
really
wrong
need-
spot.
I was gonna say, I really need to learn binary. I don't know what the hell you guys are doing there, but
All binary is you have every single slot. So yeah, this is a normal 8. The common thing you see is 8 because that's a byte. 8 slots for a binary number. That's the common one. And you can do 8. You can do all of them pretty much. Once you understand how to do 8 digits of binary, you can do more because it's just adding more digits. But the best way to understand it is just each of these represent a certain value. This is the ones value because we do this. We do like 5, 8, 1, 7, 3. We know that's 58,173, right? We know that because this is the ones column, this is the tens column, this is the hundreds, thousands, and then 10,000, right?
right.
That's what we do. We do this times that, right? Because we know that this is 50,000, bad numbering, plus 8,000, plus 100, plus 70. That looks like a 2. Thank you. Plus 3, right?
Mhm.
That's literally what's happening when we do this notation. Binary works in the powers of 2s. Each field is a power of 2s. First power of 2 is 1 because everything in power starts at 1. All numbers start at 1. Then we have the 2 column, the 4 column, 8 column, the 16 column,
I got
the
this.
32, the 64, and the 128
Yeah.
column. And so when we do these, we do 1, 2, 4, 8. And so we say 8 plus 0 plus 2 plus 0, right? And what does that give us?
Just to mention, binary can only have 1 and 0, just in
Right.
case no one knew that.
I think we talked about that earlier. That was something we did talk about because I did the whole thing. We go from binary to numbers to letters to colors to pictures to video to, we did that whole lesson. It was a quick one, but we did do it. So we did mention binary before. Yeah, we got that 8 plus 0 plus 2 plus 0 gives us what?
10.
And
And that's how we know that this in binary is equal to 10 in decimal. Same concept, same way you do numbers in human form is this. It's just we can just read that as is because there's no converting to another monetary system. The only problem for a human is that we can't really understand binary in our heads because we're not taught that from the beginning. If we're taught that from the beginning, this would look like 10 to us. This would represent 10 items on the table. That's all. That's what a computer sees this, right? So now here's a quick question. We know that when a computer sees this, that's what it does. It stores that in a byte. When I want to store the number 10 in memory, I change somewhere in memory a set of 8 bits. These are all bits to be 0, 0, 0, 0, 1, 0, 1, 0. That's what happens in memory. Somewhere in memory, that number 10 is stored like that in memory. All right. Here's a quick question for you, though. If I want to store 12.3, how do I store that in binary?
I do
Matt's
not
face just said
know.
exactly what everyone's face should have. Yeah. Everyone's brain should just broke.
I don't know.
Is that
Right.
negative binary? Is that
No,
how
I
that
didn't mean
works?
that on purpose.
Well,
That-
no, I
Okay.
didn't even see that. I was asking if that's where negatives come in, but I don't remember.
No, that's you're just thinking signed and unsigned. No.
Yeah, okay. This is the part of my Python course last year or 2 years ago that I tuned out of.
No worries.
So I can see where you can get the 12 in there, but I
Yeah, we
don't
can,
know about.
we
the
all know how to
0.3.
store this number, right? But how do we store this dot three, right? That's a difficult one, isn't it?
Well, are they attached?
Oh, we don't know if they're attached in binary. I'm not saying that. I'm just saying, and this is what's cool about this. This is just what I'm doing right now is just doing a problem solving just exercise. There's no, I'm not asking you how they actually do it.
Mhm.
I'm saying, how could you? Knowing how binary works now, how do we store binary? I mean, that's how computers store this. How would you, how, if you had to come up with a way, how could you store this in here in binary? How could you store that information?
You could use a bit.
Explain.
Well, like for example, a char is a bit because it's only one.
Mhm.
It's only one character. Or
No, char's not a bit. A char's a byte.
sorry.
It's all good. Yeah, bit is just one of these ones or zeros. A bit can just be 1 or 0. That's all it can do.
Yeah, or like I'm sorry, not a char, a boolean.
Oh, Boolean. All
It's a
right.
bit flat. Sorry. Boolean is a bit flat because it's either yes or no, true or false, on or off.
Mhm.
So that's what in Java, I'm not sure. I can't remember if there is a bit designated for a variable, but you can use the same thing. Like all it is you can use a Boolean as a bit flag for
Mhm.
yes or no, true or false.
Yeah.
Or if you actually had the bit indicator for a variable, then you can use bit for 1 or 0.
All right. Yeah. What I am wondering though, again, so that I don't know if that is looking to how do I store 12.3 in binaries? Like again, we know that we can do 12. That's 0, 0, 0, 0, 1, 1, 0, 0. That's 12. But how do I get that 0.3? That third of a number? And actually, and it's what I'm going to tell you guys actually. And so here's the funny thing about it. That's actually a difficult thing for computer science to do. Because some of you guys, like my initial assumption, if I had to store this number, I would just store them as 2 separate values, 12 and 3, knowing that this is a decimal form. This is a fraction. And so I would do that, and I would also do 0, 0, 0, 0, 0, 0, 1, 1, somewhere else in a separate system, knowing that that is a fractional storage, and I'm storing a fractional somewhere, right? The
Yeah, that's
problem
what I
is,
was
though,
thinking about linking the memory addresses together.
I knew that's where you were hinting towards. That's where you were going with that. Are they connected? They don't have to be down to the same variable, to the same byte. No, they can be
Oh.
2 separate things. That's how I would just guess I could solve it. But of course, we have the slight problem. How many potential numbers can I go this way on?
Infinite.
Right. I can go as long as I want, right?
Ooh, yeah.
Are computers infinite?
No.
No. And that's a big problem that computers have with decimals. Decimals are not compatible with binary. And so something you might start seeing if you do math in computers with decimals, you can run into something called imprecision, which is a pain in the butt. And now my big goal here is I get to find out, can I do the example I want to do? I have to find notes quick because I wasn't prepared for this today. What to see? Right. So, want to test this. Go back to main for a quick second. Oh, I also got to comment this out, so I'm going to do that. Got a float. Actually, no, I don't need float. I can do double, but we'll do float anyway, because at least I'm thinking this one's going to give me what I want. Of course you don't. Oh no, that I ran the wrong game. I'll run this.
Cliff, I'm gonna have to drop out.
Oh, okay.
Something's going on with my dog.
Oh geez, I'm recording,
It's-
so yeah, that's fine. I'll make sure it's get posted.
Something crazy. I'm gonna have to take another emergency room.
No
Okay.
worries.
All right.
Hope he's okay, or she.
All right.
Hope it's
Yeah,
okay.
it's a he. It's a he.
It's a
All
he,
right,
okay.
thanks.
Hope he's okay. Take care. That's unfortunate. I hate when that happens. Dogs, no. So what's actually happening in this code? What are we actually doing here? So we start with 1.89, right?
Mhm.
So our first number is 1.89. We start with that. We then have our int I equals 11. So I starts at 11. I is less than 800. We do I times 2 whenever we go up again. So the second
you finally get
iteration
a
this goes
pen?
through, what would this number be? What's I on the second iteration?
Did you finally get a pen?
22.
No, I did not.
Oh, your handwriting is getting so much better at this.
Yeah, practice. Not something I want to be proud about though. 22, right? So that's how the loop is going. What do we do with that number, with these numbers? We're doing what?
Multiplying it by number 1.
And we're multiplying it by 1.89. So what should we actually get when we do 11 times 1.89?
Not a double, not doubling the 11.
Well,
Should be a
Well,
fraction.
An int.
yeah,
It shouldn't be,
Oh.
like, we're going from 11 to
Really?
22.
yeah, because
So what we actually get would be a float.
Yeah,
Yeah, you get a float, but
But
what's the
the
actual?
calculation is not correct though.
Actual number.
Oh, that's why I'm not getting stuff. Launchpad. Thank you.
Isn't 11 times 0.189 should be
should be a
Okay, ready?
fraction.
22.89.
1.89 times 11. Be 20.79. What did we get though?
22, oh,
I mean, technically.
Look
if you're-
what Java gave us.
Oh, it was the 22.
Oh, okay.
Yeah,
Oh,
Java
sorry.
gave us this guy right
I'm
here.
looking at the wrong line. I'm sorry.
Yeah.
20.789.
Yeah, look out. That's not correct, is it?
No.
In precision.
Hmm.
This is the concept of precision. Now, let's say, if you were building a house with this number, would this bit off be a problem for you?
Kind of.
Really?
I wouldn't, I mean, it's off by 0.001, right?
Right. It's only off by 0.001 because it was 20.79. Only off by like 0.0000001. Five? Yeah, 1, right? 2, 3, 4, 5, yeah, 6. That's our imprecision we have right here. Now, single time, not a big deal, right? Not a big deal for that. That's not going to hurt
Someone's
us.
bank account, they're being undercut by shades of pennies.
That makes me think of the movie Office Space.
Mhm.
Exactly.
I just thought like about a calculation of like to travel from one star to another, like a number that small, but if you multiply from like for like a light year, you'll be off by like
Where am I
Like
going to go? I
like
gotta
a
go
whole-
Building
back.
a really big building, then it might
Yeah.
cause a lot more problems.
0.00001. Multiply that by 30,000 iterations. We're now at 3 cents. Not bad. 0.00001. Not too many. We do that, let's say, on the scale of how many transactions you think a bank like Citizens does a day?
oh geez.
A million.
Transactions.
A million. 15 million.
At least a million.
At least a million, right?
At least.
They're now off by $1. They've lost $1 in a single day. And
Yeah,
it's
that
only
makes
a million. We're
backwards.
I think under scale. We're undercutting this, I can guarantee.
Yeah.
Because how many transactions do one of you have a day? How many times do you process a payment in a single day?
Depending on the day, yeah, 0 one day, it could be
Sometimes
5
doesn't.
the other.
Yeah, it could be
Yeah.
10, 20 times a day, right? Sometimes.
Yeah.
And so a company like Citizens that has thousands, almost probably at least a million customers at least, is definitely doing more than a million transactions a day. And so that's something that can add up. And now if you're doing something super precision, let's say laser surgery, where your system is controlling a laser that is inside a human body,
You don't want any variation.
that can cause a problem, right?
That's your brain
Yep.
or your
Well, this
heart.
kind of a precision system happened with rocket science, actually. we lost one of the rockets. I can't remember which one it was, but one of the rockets we did launch, they had to do the blow up system. It actually went off course because of an imprecision imbalance. The code in the rocket was not evaluating its decimals correctly, its precision numbers correctly. And so this small number, after running this calculation several million times, became prevalent enough that caused the rocket to start to sway and went off course. There's also another situation where this was a major problem out in, I want to say, Afghanistan. We had these anti-missile systems. Anyone know how some of the older anti-missile systems worked? I gotta find this video. I gotta remember to find this video.
Is that where they intercept the missile coming in?
Yeah, that's one of the most common ways we stop a missile, right? We have our little missile launcher down here. We see a missile coming in. That's not a missile, but it's fine. It's just an arrow. Like an archer, but we have a missile coming in. As it comes in, we launch another rocket to explode somewhere in the vicinity. So we don't care where exactly it is. As long as it's like we explode here, our range of damage will hit the rocket and cause it to explode as well, right? So how do we do that though? How do we hit that, not, let's say, a plane or a bird? How do we know to launch a rocket at this incoming item?
How to calculate
the
speed.
trajectory.
Yeah,
Speed and trajectory, right? Yeah, speed and trajectory. We definitely know rockets are probably traveling faster than a plane, right? And definitely faster than a bird. And so we had these little radar devices that would scan the sky, and as soon as it noticed an object, it would ping the object, wait a certain amount of time, and expect it to be somewhere. And so then send another ping out and see, is the rocket here? If it is, it'd be like, yep, that's a rocket. I now know the trajectory and the speed. Here's your details. Send the rocket off to blow this thing up, right? What they noticed that due to imprecision with their clock, over time, the clock would start to fade. The clock would start getting told the wrong time. It would start to deviate from its time. It would slow down. The clock would slow down over time. So 1 second could actually take 1.2 seconds or 1.3 seconds to actually pass a full second. The longer the device stayed on. Easy fix. Restart the device once in a while. Every once a week, just turn the device off, turn it back on. Resets the clock. The slowdown doesn't happen. One device was left on for several months. I think actually maybe even a year almost. They left the device on for several months, causing the slowdown. The slowdown, I believe, was actually just I think they calculated it to be like 1.2, 1.4 second delay. So every second was actually the clock, this thing thought when 1 second passed in the real world, this thing, actually, sorry, when this thing thought a second passed, actually 1.4 or 1.5 seconds actually passed. So it's actually really far behind. So it was like, oh, only 1 second passed? No, more time had actually passed. So it was observing the world in a slower sense. So when the scanner noticed the rocket, it waited for what it thought 5-10 seconds and then pinged the location. When it did that though, 10 seconds, almost 10 seconds had actually passed. And so the rocket wasn't where it expected. It's like, oh, that wasn't a rocket. We're good. It's not there. It's not a rocket. The system didn't fire its missile, and it actually did hit one of the bases, and we did have loss of life. Imprecision is a problem. You want to be aware of these things. And so there are tools nowadays to work with decimal items. If you have to work with fine-tuned precision values, large decimals, there are tools in place for that. But most cases, you want to avoid doing math with decimals. Decimals bring imprecision. They bring imprecision. So if you're going to do math, you most likely want to avoid those. How do we make sure we don't do math with our money? And sorry, how do we, bad question. How do we make sure we don't do decimal math with our money?
What if we change that to a double?
Honestly, it doesn't matter if it works here, it's still a scenario, but yeah, the double works. Because I think the double contains more imprecision, but I'm sure we could trigger the imprecision if we went farther or did more numbers or did more complicated math. Main thing is just computers don't handle decimal well. Main thing you gotta remember. So how do we take
Another way to handle that would be what you said with the binary, just store the decimal as a separate number.
Could do that. And I think that's actually how they do it. But in our situation though, so let's say I have $23.72. I don't want to do decimal math though. So what could I do with this to make sure I don't do decimal math?
Cast it as an integer.
Well, how could I do that? Pass that as an integer? It's $23.72.
Multiply to get rid of the decimal places.
I could multiply, but that's still technically doing, I'm still doing in decimal math, right? I'm multiplying this by 100 to get rid of the decimals. Yeah, but I could still argue that I am doing decimal math. What else could I do?
The only problem I foresee is that if you got rid of the decimal, how would you know where the decimal is down the road? Where would it be? Where
True.
would it lie?
Good point.
Have a dollar balance and a cent balance.
Could do them separate, dollar and cent. So I have $23 and I can start 72 cents. Is there any other ideas?
Wait, I'm confused.
I don't want to do decimal math. I don't want to do decimal math with my money. How do I prevent myself from having to do decimal math with my money? You guys are gonna hate when I show you the answer.
You don't. You leave it as the same.
You get rid of the.
I store it as
Oh,
cents.
Answer?
Oh,
I don't store it as dollars in any way, shape, or form. I understand money is just cents, period. There are no such thing as dollars in the computer system.
that works. Okay.
My money is stored in the bank as cents. And I can guarantee you for most of you, that is how your money is actually stored at the bank. Your bank recognizes all money as cents, not as dollars.
That's
In order to
I got a
display
question.
dollars, it just divides by 100 or just puts a decimal point, 2 dots in. What's the question?
So what, even if you have it as cents and you calculate interest,
Mhm.
won't there be an issue with the decimal?
Potentially. But again, if I wanted to do interest of, let's say, 0.05%, what's another way to understand that? How can I do this? Any ideas?
You could just multiply that by, or divide it by 100.
I could
You do the same thing.
represent
you
this
did
as
for the
5, right?
dollars.
And
You
then if
could
I do this
move the
as,
decimal point.
like, you can do percentages without actually doing a decimal. That's one thing to keep in mind. I'm trying to remember the math. I don't have my notes up to remember it because there's a way to do it.
Well, you
Yeah,
will multiply that by 100.
I think you multiply both by 100. So you multiply
Well,
this
that'll
by
hold
100, so
number.
you get 237,200. And now I just need to apply that to the number 5. I don't actually do the math here. I just know that when I want to apply the interest on this, I multiply the cents by 100, which is no decimal math, do this, and then I can divide by 100 and lop off and do integer-based math so that I lop off the decimals. So once I get the math here, let's say, so we do, let's go to the calculator, 237,200. There's my calculator. Where'd it go? Did I close it? I closed my calculator, didn't I? There it is. Ooh, this is fun. 237,200 times 5. I get 11,86,000. And then I would do integer division of 100, which means I do division, but I don't do decimal division. I get rid of 2 zeros and I just lop them off. And so my end result is 11,86,000, which is $118.60. That seems like a lot, actually. What did I do wrong? I did something wrong, I feel like. Was it multiplied by 100? Was it? I'm trying to remember this now. Dang it, I wasn't expecting this. I forgot my math formulas. Nah, it's not multiplied by 5. 2, 3 dots. Oh, right. No, I remember what it was.
Hey,
7, 2. Divided by. Oh, no, I'm gonna have to look it up again. There's a way to do it. I just can't remember it off the top of my head. But there's a way to do this without having to do integer-based math on this. But again, that I could do. I could, if I want to. My main goal is to minimize how much decimal-based math. I wasn't planning the example on this right now. I just want to make sure that people understood that you don't always have to store everything as decimals. Consider, can you store it otherwise? we don't care anything past this second digit of the change, right? We don't care about a hundredth of a cent. We only care about cents. And so we can 100% store our money in our bank account as cents. We don't have to store them as full dollars, right?
So if your math was right, that's just like a really high interest rate. A bank would never pay that.
I did 5%, I think is what I did. I didn't do 0.5%.
Yeah, like that's not a
yeah.
realistic rate, but that's a correct math.
Okay. Right. No, you're right. Yeah, I did 5% interest rate, didn't I? 0.05 is 5%. I didn't do 0.05%. I did 5%. So it would have been a couple extra zeros on there, wouldn't it? Been, yeah, 2 extra zeros. Yeah, I would have to get rid of like, yeah, 2 more dots over. So then like, or one, where is it? Yeah, the dot would have probably gone, where is it? This one, that one. What was it again? Let's see. I want to actually now I just want to do a quick check because I think you're right. I didn't do enough decimals. Later.
Yeah, that would be 0.0005.
Then oh wait, hold on. I don't need to add those there. 2, 3, 7, 2, 5. Actually, zeros don't I? I get rid of so the zeros. I feel like I'm doing one too many zeros on the first result or the end result. There's too many zeros showing up. I can't remember what it is. So I think it's supposed to be somewhere in there. I'm close. You're right. I didn't do the right math. I'm doing 5% on that, not 0.5, 0.05%.
0.05%. The interest is like $1.18.
Yeah, that would be the. Oh, right. I'm figuring out the interest. I'm not figuring out the total balance. That's what I'm doing. Yep. I am right. Yeah. So 2, 3, 7, 2, 0 times 5. That, but then yeah, that's like all the way over here. It's like, yeah, 4 decimals in. 1, 2, 3, 4, 5, like somewhere over here, like 1.186, something like that. The exact decimals I have to double check again. Things like this is the actual interest I'm going to get. 1186 cents in interest. This is cents still. But actually, it might be this. Actually, I might get rid of the 6, I think. I don't think the 6 is there. I think it's 118 because we're going to do the decimal drop. And this is the amount of interest I get. So because if I do 2, 3, I actually do the math now with the decimals. 2, 3.
My bad. I didn't mean to throw a curveball.
Times 0.05. Yeah. Okay. Cool. That's 5%. So yep, 5% of that is that. So I was there. I didn't remember what I was doing. I was getting the interest amount, not the new balance of my bank account. And I just didn't move the decimals over enough.
So now would that mess it up though because of that extra 6 there at the end, or does it just round?
If we do integer division, we're just going to drop it. We're not going to include it. If we do integer-based division, we're just going to get the 1.18. We're not going to round up. And I can guarantee you when a bank is awarding you interest, they're not rounding up. They're going to keep that 0.6 cent. That's how they make some of their money. The rich get richer. Yep. They floor any interest and they ceiling any fees, any charges or anything like that. So, okay. Sorry for the curve. Thanks for the curveball, David. But yeah, no, I wasn't ready for it, so I did not prepare myself with the right math. But I did have it right. I just did not explain that well. Hey, again, you can do this without decimals. Again, we can definitely do we can even calculate the interest without decimals. 100% can be done. But the main focus again of this was just we want to avoid as many decimals as we can. Does that mean we never do decimals? No, that doesn't mean we ignore them like the plague. Just if we can, try to avoid them. And so, like I said, with money, we're always just so used to seeing $23.72, and we don't think that it's like, oh, all 23.72 is, and that's a horrible 72 there, is just 2,372 cents. All it is. There's nothing special, nothing fancy about it. So with that little side tangent out of the way, what should be the data type of our balance?
long. You do an int, but
And
Right. Yeah, and we can do long, I
Double.
guess. Yeah, you can do long. Double's a floating point, so can't do double. So we don't want
I
float or
mean,
double. Those are
right,
floating points.
I would go along if we're just gonna keep it as
Int
cents, because it
or
can get a
long.
big number.
Yeah, we enter long, one of those two, depending on how long we want. Now, since we are doing cents, we have to think about like how much, like, if we were to say that a person in our bank, what's our max int again? Let's look that up again. What's max int?
yeah, like max int is pretty huge. And since it's a simple application, we can always use an integer.
Integer max value is this, and if we take a look at that, what number is that? So let's go ahead and do a dot here, and a comma, and a comma. So that means anyone in our bank account could have $21 million roughly.
Woo!
If they had any more than that, our bank wouldn't be able to handle it. So should we do a long? Probably wouldn't hurt to do a long.
We need to.
Yeah,
What if we borrow money from the Federal Reserve?
exactly, yep.
what if
Our
it's a
total
government
value
account?
of our bank might go over that. Maybe it might not be likely that that a single client might have that, but definitely our bank as a whole could have more than that. So this could be the start, and we definitely want to hope that one day we have someone that has more than 21 million, right? Be great to have as a bank. So could you start with an int? Sure, yeah, long's fine. That's good. As long as it's not a floating point, I'm happy. Yeah, long would be fine because we can then go over 21 million. Let's get rid of my mess. A lot of the way, the Zoom thing. I think I see a chat. Anything important? I missed. Oh, David. Okay. All right. So we have our public private long balance. Any other fields? Let's do one more for now because I want to get to the other stuff.
Name.
Yeah, probably like an owner. Yeah. That's, I don't think I need to ask you guys what to do for that one. Come on, keyboard. Private string name. What are those? One more. There's one more that I really would care about that I want. Let's see if anyone thinks of it. Think of an ATM.
Account number,
We already have a account number. That's ID.
PIN number, PIN number.
PIN, right? Our security system. Well, I don't just anyone pulling the number, do we? Yeah, we can do that as a string or int. What do we want to do?
String.
String.
Good. Can anyone explain why we might want to do string instead of math instead of int?
In case you want to make it Bosco.
What's that?
Bosco, that's an old Seinfeld reference.
Oh God, is that like 0000?
But no, that was George's pin. It was Bosco.
Oh,
It's like Hershey syrup or
right.
something. I'm an old soul.
No kidding, but I was thinking ATM. They only have the numbers now. Yeah, the numbers do represent
No, but
letters.
it
but
could
they're
be
type of
letters.
numbers.
It could be letters though.
In this case, we now could have a pin with letters now. But the other reason why we want to do a string, even if we only had numbers as our pin, why? Let's say we're only doing numbers as our pin because we have the ATM. So I'm
Because
thinking
you're not going to
ATM.
be doing math on it.
Not going to do math. There's one
And
more
someone can
reason.
hack it.
How
Because
so?
if it's just numbers, I can just finally pick those out. If it's letters and numbers
Yeah,
and numbers.
ATM, not computer. So you can't run a system against an ATM to keep trying different pins.
Oh, I could use one of those card swipers, don't I? One of those things you plug in right into the machine and then
No,
read the
that-
card.
No, they only
skimmer
skim them. They don't
takes your card
run
information.
anything on it. Yeah, they just take the information. They don't actually run anything. They're skimmers. They
I thought
scan the
the
card as it
skimmers
goes in.
take
It doesn't actually do
PIN
anything to the
number.
computer itself. What's that?
I thought the skimmers take your PIN number and take like your. all your
No,
personal
they can only take the information on the card. Now, they could install a camera on it that is monitoring the ATM keyboard so they can watch you type it in. If they have that, then yes, they could. But no, the skimmer only scans what's on the card. It's the same thing they use that a waitress can use if they have it attached to their hip.
If they don't put a camera in, or if they don't see you enter your pin on the camera, then they can still do a lot with that card information, that account
Yeah.
information,
So they wouldn't get the
like
pin.
ordering things online and whatnot.
Yep. Yeah, they could definitely order online, 100%. Yeah, they wouldn't get the pin from the skimmer. But again, if we're using just numbers for our pin, why would I want a string other than int? Bypass the fact, yeah, we're not going to do any math on it. There's one more reason.
Oh, because you can't use zero.
Kind of. What do you mean I can't use 0?
Well, I can't put zeros in the beginning of my pin because it'll just get
Right.
wiped away from an int.
That number is an int is what?
384.
Yeah, it's not 00384, it's 384. So the string I can do 00384. That's why, that's the other reason why we're going to pin. So again, that's one main thing here. I'm just trying to get you guys to think critically, deduce reasoning, all that fun stuff. Is that once you have the first reason, we're not doing math on it, that's valid. But it's always good to think of other reasons too. That might not always be the valid reason. So good. And my goal here is to make you guys think. So that's the other reason.
I gotta step out for 1 second, excuse me.
Go for it. Because I could see that some of you might be able to might want to argue that possibly, well, we are going to do comparisons on it, and it is easier to compare ints versus strings. And so while you might think we're not doing calculations on it, we are doing comparisons, and we do know that strings, you have to use that dot compare method or dot equal method, and that's annoying. Whereas ints, you can just equal, right? And so you might forget we're not doing calculations, but might think that, and that's why it's good to also know the other reason preceding zeros are lopped off. So, make sense? Cool. That's why I want to challenge you guys to think aggressively about stuff. All right, so we have that. We have our private methods. Then I'm going to build a quick constructor. So balance string. All right. So we have those. I'm going to do a quick thing that you guys do not have to do with me. I'm going to put these all back to public for a quick second. You don't have to do this. I just want to do a quick showcase on things. Public. We have that. Let's go back to main. I'm going to create a bank account now. Who wants an account with the bank of code?
Okay, I'll take an account.
Thanks, Elaine. You trusted me with your money. My very weak code right now. You know what? You're one of our first customers. You get to pick your ID. What do you want your ID for your account to be?
I want my
Your account
ID
number.
to be 7612.
There's a reason for that, and I'm not going to ask unless you want to share.
I just made it up.
Oh, okay. All right, we're going to give you $850 in your bank account.
Oh yeah, excellent.
Yeah, 50. Looks like you have 85,000, but remember it's 85,000 cents. So you don't have $85,000, you have 85,000 cents. So got that. Let's go ahead and do our name. So that's going to be Elaine. Our pin. What's your pin, Elaine? Don't give us your actual pin.
7612.
All right, same as your account number. I would
Oh,
strongly
I'm
against.
sorry. I'm
advise
sorry. I
against that.
didn't want to make them. Let them be the same. It's all right. No, we'll do it backwards. 1276.
It's not technically backwards, but fine. 2176, but or 2167, but it's all good. We're just reversing the two digits. We're doing 1276. It's different enough. I'm going with it.
Just so that when we run something, we know that's not the same.
Yeah,
Which
there you
number?
Have a checking count. So have a checking count, and I can do. Let's go ahead and do S out. Elaine. I also want to do some interesting stuff here. S out. Oop, not synchronized. That's not what I want. Oop, not that. Balance. Let's see if I can at least look at those things. All right. I got the, you know what that is, that's our attribute, but look, I can see that perfectly fine, 8,500 right there. So now at first, this doesn't seem like a big deal, right? I can change it, who cares? I'm the one editing it. I'm not gonna do things. Now that I can access it, I could definitely do this. Balance Actually, I'm gonna be the evil person. Actually, I'm gonna take 1,000. I'm gonna take
Oh,
10 bucks from her. And take 10 bucks out of our account.
well, this is an expensive bank.
Yep, take 10 bucks because if you like it.
I'm probably moving to a new bank really soon.
See, nothing, no problems there, right? I just zapped 1,000 cents out of our account. Right? Not a good thing, is it? Again, though, if we first think about it, I'm the developer, I'm building this, I'm not going to do that, right? I can say that at first. In the beginning, when you guys are learning, that's why it was fine for you guys to use public. Didn't matter. You guys weren't going to implement malicious code. Let's say I want to have, what is it? Let's say I want to have Sergio go into checking account and make a change to the file. So he can go in, make some changes, but then I see that he changed something in here. I'm going to go in here and I say, okay, I see the changes, it's all good. But hey, so we can do this. We're going to do public. Do a quick little thing here. So Sergio comes in, does a public void public int with raw int amount. And so I'm going to go ahead and actually don't need that. We're just taking the money. We're just removing the money. So we just do void actually. So we do void. Yeah. And so here I go ahead and do this dot balance minus equal amount, right? Now, if Sergio was the good developer, this is what he'd code. The malicious developer, he could also do this and do, oh, I'm also going to take another checking account. X, or do checking account X. I'll take that account. I'm also going to do X dot balance is equal to the amount. I'm going to take that amount that I just took out. I'm going to put it in mine instead. Or at least maybe I'll take a portion of it, you know, right? I'll take some of that. I'll say, you know what, amount plus 5. I'm going to add to my account amount plus 5. So I'm going to remove 5 more cents from this transaction. I'm going to add it to this random account I just stuck in there, right? A little bit malicious, isn't it?
Yeah.
What could that account be? Well, let's run a little quick check here. So I'm going to go back to main. Yeah. Sorry, Sergio, I'm picking on you, but making you out to be a hacker. But hey, you can at least say, I was a hacker for a couple seconds. What's your ID for your account, Sergio?
4455.
Well, that's the ID, not the PIN number yet. So
No,
balance, we'll start you off at just $100 or 100, yeah, $100. Not too much right now yet. What's your code name? Because you definitely don't want people knowing this is yours.
Panda.
Panda. All right, work for me. And what's the PIN for Panda's account?
3453.
And just to make it safe, we're going to rename this to Panda as well. So now we're going to go ahead and do, instead of this balance here, removing it this way, we're going to actually use the withdraw method. Withdraw.
Send me coming up there, Cliff, on line 6.
Thank you. Let's get rid of that one. So lane dot balance, we withdraw 1,000. Why is it yelling at me?
Because
Oh,
you
I
need
need the
to
account, check account
second,
too. I'm gonna pass Panda to it. What I'm also gonna do is I'm gonna do the print the system out again. Or Panda though. Play. Take a look at that. Elaine actually took an extra 5 cents out of her account, not the 1,000 she requested. She actually lost 1,005, and Sergio and Panda's account just gained 5. And so if we then ran this against multiple different checking accounts over and over again, what would happen to Panda's account over time? What?
Keep growing.
Rich.
Hey, he'd make money, right? And with these small amounts, like we're definitely making it a little more obvious with 5 cents, but if it's just 1 cent at a time, that'd be hard. It might take a while for people to notice it, right? That they were missing an extra cent out of every single transaction they did, right? And I think this was the plot of a movie, wasn't it?
Yes, office
I
space.
think it was, yeah.
Office Space. I actually feel like it's a plot for several movies, honestly. This scheme.
Well, they got that idea from a different movie.
That's what I'm
In
thinking.
Yeah, in that movie, they got the idea from a different movie.
Oh, did they really?
Probably,
Yeah, I forget what the original movie is though.
probably. I don't surprise
And
me.
the original movie was probably based on real life events.
I feel like, was it movie that had the bank and the guy who died? Ghost? Wasn't that thing a bank?
Was it
situation in there?
Ghostbusters?
No, I think it was just Ghost.
Yeah, with Swayze.
Yes,
Oh,
that
maybe.
guy, that movie, right?
Yeah.
Is that what happened in that one? I knew that there was a bank thing. I don't know
Yeah,
what
it was similar to that.
I
I
was
don't
so
know if
young,
they
I
would,
just remember the whole pottery thing.
I think that was some sort of real estate deal through a
Oh,
bank
okay.
that went.
I just know there was a bank thing in that one. I don't remember what it was.
This video definitely needs trimming.
Yep. But we have all that there. So this is kind of the evilness of the public system. So it actually doesn't show the evilness of the public system yet. But what this does show is that malicious behavior can happen inside the class. But if I gave this to Sergio, he gave it back, I'm going to simply look at the code he modified, especially when he does a pull request or push request to my system. I'm going to look through the code I'm expecting him to edit. I was expecting him to edit check account. So I'm going to go through check account and I'm going to look for anything malicious. I'm like, dude, what is this? This is no, that you're trying to hack stuff. I'm firing you, right? Instantly, because I see this problem here. In a different sense, if I had him build an ATM class, and in that class, he had a transaction or withdraw method, and in there he put the malicious code, it might be harder for me to see, because then he can just access the balances of certain classes directly because the balances are public. He doesn't touch the checking account, doesn't put anything malicious in the checking account. Checking account is left alone. He slides the malicious stuff in his other class, and it's less obvious there. If the balance though is private, he needs to have access to be able to withdraw. And so we can do in this case, the withdrawal instead should be, let's make it private. Keith is back, nice. Make it back to private. And in this case with the withdraw now, we're gonna do something slightly different. We need an amount, and what do you need to withdraw money from an ATM? You need an amount plus what?
Passcode.
Yeah, your PIN, right?
Right.
We can call it code if you want for this, but yeah, code, so we have separate from the word PIN. And what I'm also going to do is do a public, or just do private actually now. Void set balance. And so this is a private item, so only the class can do this. And so if this is hit by the class, it should be authorized. This is now allowed. So I can do balance plus equal amount. In my withdraw method though, now I'm gonna add the logic to say whether or not I do actually run set balance. So withdraw is gonna decide, do I do the set balance or not? And so I'm gonna do if code equals PIN set balance amount times -1 to make it negative. So I'm doing plus equal. So I want to make sure it's a negative balance. So the negative amount. It's just ensures it's a negative amount. And for some of you who are like, well, what if he sends in a negative amount? Handle all scenarios. I do the absolute value of it, then multiply by 1 to make sure that whatever number I get here is a positive value, and then I get the negative just in case, because I can't guarantee that the person sending money here is always going to send the negative amount, can I? So for any of you, because that's something that you can really have fun with creating your systems. Think of all the ways you can be malicious, right? No, let's say, yes, I did allow it. I got through here. I didn't do the -1. I just did the amount. Another malicious thing could be to submit a withdraw. It says I have enough, but then instead of sending a negative amount, I send the positive amount. And so then I'm adding to my balance when I withdraw instead of taking out balance when I withdraw, right? There's another way of being a malicious actor, sending in positive amounts to my amount. If I just do the times -1, well, now I'm just going to start sending negative amounts. Negative amounts gets converted back to a positive amount. When you multiply by -1, I'm again adding to my balance. So the only way to handle both is to assume that this could be either convert it, make sure it's positive in the beginning, and then converting it to negative. And so this is where you get into error checking for customers. But always make sure, again, you start with your logic as understanding that this is going to be correct. So this is a good V1. This is your MVP. Assume that the amounts are going to come in negative every single time. You can also assume that in this method here, you can always assume that there's another method that's going to validate the amount, right? I don't have to do the validation here if I don't want to. I could have another method somewhere else in a UI system or an ATM system that's going to confirm that the amount being sent to the system is already set to a negative number. So I don't have to do it here. And so those are things you can also do as well. So you could always leave this here and something else can deal with the negative. Again,
But
there's
does
multiple ways to handle it.
that kind of, no, I get what you're saying about that, and that makes sense also, but
Mhm.
just the question I would have is that if you're finding you're making validations in various classes for this one withdraw method, shouldn't you put the validation in there to consolidate it and not have code running
Depends.
all over the place?
If those validations are useful for other parts of the system, then no.
All right,
If you're going to use the same validation for both withdrawing and for, let's say, what's the one for depositing too, you could use a similar validator, just understanding the different variations of it. That's something you can use. So that's something to keep in mind. You can definitely change how you want it to be. It depends on whether or not that validator is reusable. If it's not, then yeah, put it right into your code. And that's why I'm doing this here. I don't know yet if my validator is useful in more than one location. So math, ABS, times -1, and now I'm safe. And when you're first coding, don't try to handle all errors. You're doing way too many things at once. Assume the values are perfect first, and then either add a validator somewhere else. Assume in the beginning, assume the validator already exists. Assume perfect users. Know that that is an assumption. Be very much aware that what you are assuming is an assumption, and that at some point you will get malicious users, and they will submit bad code.
How come you wouldn't add this in the set balance? Like the checking?
So in this case, because I might use set balance in other methods. So again, deposit, I have this one method here that is private, and so I can use it for both.
But don't
adding
you
funds
always
and
have to,
subtracting funds.
don't you always have to check for that in set balance though, even if it was in another?
Not necessarily, because what if I'm the bank applying the interest?
Okay.
Yep, I wouldn't want the pin, would I?
And the only reason I bring that up is because Moss shows his setters and getters, and he's
Yep.
always constantly using that error checking in his setters.
Yeah. Again, that's where you can do it. You can definitely do that. You don't have to. It's all that. But the main thing that I want to point out is that yes, your setters and your getters should be logic based. That's the big key thing here. If you just have a setter, which is like this, let's say we have public set balance, just have it equal to amount, public void get balance. Oop, that's not void. No, what is it? It's long. Get balance. This, for all intents and purposes, is now a public field, isn't it? So I can access it freely and I can edit it freely with no issues, just like I could before when the item was public, right? And so, and what you'll see in a lot of companies, that this is considered bad practice. If you have a setter and a getter that has no logic in it, just make it public. You're wasting code space. It's not looking good. And you're also adding more typing in your code later on. Instead of just doing a lane.balance, I do a lane.get balance and a lane.set balance. And I can't use the equal operator anymore. I can no longer use the assignment operator in a private system. I have to then send it as a parameter, right? Whereas if I use a public variable, I can use the assignment operator. I can use plus equal and minus equal. I can use all those cool assignment tools with a public variable. Can't do that with a getter and a setter. A setter also isn't treated like the data type. So if the setter is for, let's say, a string, I can't use a lot of the string methods when I'm doing setting, and I can only use them when I do get, and I have to get it first, then use them. And so I have to even do that in a parenthesis, and it's a little annoying. So if you're doing these, there's no logic behind it, just make it public. Your setters, 100%, you should only need a setter and a getter if there is logic, or if you only need one or the other. In that example, we want to be able to get the ID at any time. We want to be able to see the ID whenever. That's a thing that should be safe, but we shouldn't be able to modify it, right? Setting it shouldn't be allowed. Once it's set, it's set. We should be able to pull it whenever we want to make sure we got the right person, right? if we're looking for this ID, I need to be able to make sure I got the right account, right? So while private, I can definitely do the public string get ID. I now have access to pull the ID, but I cannot modify it.
Yeah.
I can do these now because these aren't allowed anymore. Again, I can do panda dot, I can do s out, panda dot get ID. If I try to do panda dot ID equals that just to mess with the system, it doesn't let me. If I do the set ID, well, that isn't defined, so it doesn't work. I can't set ID, that's not a thing. So it protects the ID from being changed. I can also do that, of course, as some of you know, with final. We know about final now, so there's another option, but I'm just showing Gase the other way we lock out items that can be changed internally, but shouldn't be able to change
Now
externally.
that's abstraction, right?
Exactly. This is all about abstraction, being able to hide things and pull things away. Oh, wait, I don't know if that's abstraction actually.
Is it
It's
encapsulation?
That's
Yeah.
it. That's it. Yeah, encapsulation. I'm encapsulating these items inside their class, and now I'm isolating them as well. So now make sure they belong to this class and they sit in this class and they're protected by this class. And only the items that should have access have access.
So abstraction would be making your methods private.
Yes and no. That's where abstraction and encapsulation kind of get confused a little bit.
Yeah.
Abstraction is the idea of being able to use it, but not understanding what it's doing. So I can use the method, but the way it's performed is abstracted away from me.
Yeah.
Again, the idea of how I can turn on a car by either hitting the button or turning the key. What it does to actually turn on, I don't know, but I was able to turn on the car.
I think if you did IntelliJ, IntelliSense or whatever it's called, if you did that and you try to create a setter and getter, it automatically assigns these as private.
Probably because, yeah, you don't need them if you have public. And what their goal is, they're giving you the templates so that you can add logic. That's what they want you to do. They want you to add logic behind it. That's the intent of it.
I could be wrong, but I think I'm pretty sure they say it's
Could be.
private.
I don't use it. I don't know.
So like, yeah, the abstracted class. Like having an abstract class and having ID, you could have a checking account ID. But you can also have, like in your job, you can have an employee ID. They both are IDs, but they're completely separate, different
Here's a quick
numbers
question,
and
actually, to help with
different
abstraction a little bit. Again, I'm not going to go in. We're not going to do anything with abstraction today, but just a quick understanding
No,
of it,
but
make it better. Because I don't think that's going to work.
Yeah.
The IDs are the same. So the ID is a bad example for abstraction. Withdrawing from a bank account and from a checking account and a savings account, are they identical? If you withdraw money from a checking account and you withdraw money from a savings account, is that treated exactly the same?
Yes.
I would think so.
It's just different accounts,
Yeah.
but it's probably the same process.
A lot of you don't transfer or extract funds from your savings account very much. There actually is a limitation to it. You are only allowed to withdraw from a savings account 8 times in a month.
They actually did away with that post-COVID.
Oh, cool.
I
That's
used
awesome.
to work at a bank and they gave me like a specialized account.
They completely
Probably
did away
gonna-
with that one.
They'll probably put that back soon then.
No, I asked because I was like, I have like a money market, and she's like, oh no, they just did away with it.
So then
funny.
right now, I don't know of any benefits for savings account other than the interest rate, but then again, that doesn't really do much because the interest rates are so small. Interesting. So it used to be a difference. So interesting. Yeah, but I didn't know they got away with it. They got rid of it. Cool. That was a thing, by the way. And you might still get alerts for it. I'm sure they still might tell you you're not supposed to. And I wonder, do you know if a bank could put that as part of their rules if they wanted to? Because it is a private business. I wonder. So I'm looking to.
I
But
think I
anyway,
have a good example of abstraction with when it comes to like an ATM.
Go
So
for
like
it.
when you're doing a withdrawal, like you know that sound that it's making in between,
sure.
like that's abstraction. Because you're just
Yeah, 'cause
waiting
you
for
don't
the
know what's
money.
doing-
It's like doing all that stuff,
Yeah.
all the buzzing and whirring, like you
Sure,
don't know what's
it's
going
doing.
on, but that's abstraction because the process is happening.
Yeah,
You're
you don't know
all
how
you're
it's doing it.
expecting is the output, which is the money.
Yep, and we know that all ATMs can not extract or deliver funds. They can all of them hand out funds, but most of them do the $20 only, but some of them do 20s and 10s, don't they?
Yeah,
Some of them do
Right.
20 cents, fives.
They do
Some of them do
hundreds
those too,
too.
yeah. Yeah, some of them have different values, but they say that same concept of withdrawing funds. As a human, we just hit withdraw and we just enter the amount we want. How each of those ATMs handle just 20s or multiple values, we don't know. We don't need to know. And technically the ATM software doesn't technically need to know how the ATM does that, just that it does, right? The ATM software can just ask the machine, hey, I need this much money. And then the ATM just says, here you go, right? So the software doesn't need to know how the machine gets the funds together. Even multiple ATMs can store and pull out the funds differently to make sure that it doesn't overgive you an extra 20 or not, right? We don't know what safety systems each ATM machine does to make sure that it doesn't give you an extra 20 here or there, or make sure it gives you enough 20s. It doesn't undercut you either, right? We have to trust these systems. And so the software has to trust the machine, right? And so that's one of the cool things. That's a great example of abstraction. Great example there. Yeah. Now they ruined my checking account, savings account abstraction. Dang it. But the idea though is that even with the checking savings account, we go back to that older version, that idea that even though both accounts you can withdraw from, there was a difference in withdrawing from a savings account versus the checking account. The savings account would have to check to say, well, have you withdrawn 8 times this month? If yes, you can't withdraw. If no, then you can withdraw. While at the checking account, as long as you have the balance, you can withdraw. So a checking account abstract class could have a withdraw method declared, and then the savings and checking account would just define it differently. And how they would test to see if you're allowed to withdraw from that account would be implemented differently between the two. So that's abstraction. Again, that's what we're going to talk about next week. That's next week. Today it's still this. What time are we at? Can I cover the final one? Yep, I want to do one more then. So let's do. What do I want to do? Change this to bank account for the moment. All right, I'll do it that way. I'll do. We're not going to change it. I'm just going to copy and paste this into a new account. I also want to show the other one called protected. So there's another one I want to do. So I'm going to do new package. Thanks. I'll put it inside our abstraction class. I'm going to, or not banks, sorry. Rename. Accounts. I'm going to move my checking account there. Refactor. I'm also going to create a new class called bank account. So you may argue maybe this could be an abstract class. Keep that in mind. We're not going to do anything today, so I'm not making this an abstract class. We're just going to make it a class. I'm going to take all this code here, everything from the bank account class, from the checking account class, I'm going to put it in the bank account class. Taking everything with it. All right.
You gotta change checking account to banking account.
Oh yeah. Thank you. Yep. And main, I'm just going to get rid of all the code there for the time being. Get rid of this code. Do that. And comment that out for the moment. So that's how we switched it over. So we added a bank account, put everything in there. Checking account is going to be a child of the bank account. So we're going to do extends bank account. And we're going to give it one more item called fee. And this is going to be the monthly fee we get charged. We're not going to actually use this field, but we just want to have it. So. Yeah. Private fee. And now in order to extend it, what does it need? The default constructor. So save us a little time. To know that and create the constructor super, just to make it easy on myself. Normally I wouldn't do that, but I want to get to the important stuff. So go ahead and use that create constructor for this time. I won't allow you to get away with it. All right. we know that what we're gonna do, this is gonna be a horrible bank. This is not just a monthly fee. This is actually gonna be a transactional fee. All right. I'm gonna make it a very evil bank.
Bank of America.
I like it.
They're evil. That's what I have. I don't know.
Oh, you
I-
better get out of that, Sergio.
Are they? They're evil.
I don't know.
I went with
What
them
do
for
I
like
know?
10 years now, so I'm a loyal customer. They
Get with
better-
the credit
private.
union. Get with the credit union as quick as you can.
Private set balance, like we had before. Let me do void again. Again, I don't need to override this because set balance in the parent class is also private. So int amount. What I'm going to do here is I'm going to do if amount is less than 0. I want to attach the fee because that's me charging funds. If I'm depositing, no fee there. But if I'm withdrawing funds, I'm charging you a fee. That's how evil of a bank we are. What's our fee for our bank? How many?
Sound familiar, Sergio?
What's the fee for our bank? What do
Why
we
is
charge for
private at?
transaction?
It's,
Why is
$5
$2
$5 is like the standard fee
$5?
See, $5.
All right.
for like
For every time you swipe the card.
oh shit.
Maybe like 2 cents.
No, I was thinking like monthly fee or.
Yeah, I switched it.
All right, cool.
Why is,
Showed you a bank.
why is the private red?
Oh yeah.
Because it is actually still there. It shouldn't be. It's not protected as private. Time being, I'm going to comment this out for a quick second. It shouldn't be letting me. That gets in my
Yep.
head. Yeah, see, so here's the one that was kind of confusing there. I don't actually have access to that method because, ready for this? What do I have missing here?
Balance.
The term balance, right? Wait, is set balance public now? Oh, I did make it, but when did I make it public? Oh, I didn't change it back.
You make an example.
Dang it. Okay, hold on. That's what's being messed up. I didn't switch it back to private. I had this thing public at one point. So remember this will be private because the withdraw calls it. Right, so now this should be fine. Yep, okay, now I can have a private set balance. So again, balance, what is missing here? What can I not access? Even though I'm a checking account, what should I have access to, but I don't?
The
What do you
you
mean?
said the balance, but you need to have an ID or a name at least, right?
Balance.
All right, I don't have access to this balance field, do I?
Maybe like this or something.
Try that.
Hmm.
Nope.
It's
Look
'cause
over
it's
here again. Take a look at
private.
balance. What is it? What's wrong with it?
Balance is private.
Well, it's a private and you need to use the setter and the getter.
Right. So keep that in mind. Inheritance does not open up private items. So do be aware that inheritance does not earn me access to those variables. It is still private. It still belongs to bank account. Even though I do inherit that value, that property, that field, it is still considered private and I don't have access to it. In this situation, though, it does feel like I should, right? This is one that I should definitely take ownership of. And so that's where protected comes into place. Protected makes it available. If I go back to main now,
Can't get it from there.
I still do not have access to it.
Nice.
Protected says as long as they're part of the same package. So classes in the same package, as well as children, I believe, if I remember correctly, can access those variables, those fields. Those fields are passed on with full access. So protected is a middle ground between private and public. Public, everybody has it. Private, nobody can touch it. Protected, my family can touch it. In a way, if you want to look at it that way. So use the term parent and child. Simple, right?
Oh, yeah.
Cool. So those are your three main access modifiers. Are there others? I'm pretty sure there are. Those are the three you're going to use. Those are the three. If you have those three, you are solid. You can definitely use others. You can learn about others. Those are the three that you want to know now. I've already talked about final, all that stuff, but yeah, protected, private, and public. Those are the three access modifiers we are going to be playing with. All right. Sound good? With that being said, tomorrow, at the beginning of class, there will be a challenge to build something with access modifiers. All right. I'm going to build up I'm going to have a problem ready for you guys. I'm going to try to build something accessible with the correct accessibility. What I'm going to do is when we start class together, I'm going to try to hack your system via your access modifiers. So if your stuff is incorrectly set, I'm going to try to access certain parameters that I shouldn't have access to and see if I can access them. All right. That is the challenge for tomorrow. So definitely read up a little more on these, play with them a bit, practice with bank account and other things. Try to make sure you understand how these access modifiers work. All right. And that's what we're going to do tomorrow.
Okay.
I'm going to try to trim a little bit of this. I'm not going to be able to trim everything, but I'm going to try to trim a little bit of this video and I'll try to get it up as soon as I can. All right. That's why I'm actually going to end it now, even though it's only 8 o'clock or just before 8 o'clock. So, and now I want you guys to keep practicing on this, but mainly for those of you in Liar's Dice, you got your recommendations. Feel free to modify those, read up on them and trade. Oh, yes, good call. This is still part of the Yahtzee system. So I wonder if I should rename my repo to just cohort 12. It's fine. It's still in Yahtzee.
They're recording if you're gonna stop recording.
Yeah, let's do that. This part you don't need.